So first question is longest substring without repeating characters. So we will be starting from the playlist sliding window. So given a string s, find the length of the longest substring without duplicate characters. First of all, what is a substring? A substring is a part of a string which is consecutive. Suppose here in the example you can see ABC is a substring. A is also a substring by itself. AB is also a substring. CAB is also a substring, and this is also a substring of itself. So this is a substring consecutive, and it is given that without duplicate characters. So characters should not repeat. So I can see ABC is a substring which is not having duplicate characters, and it is longest, I think, because no one is of 4. So see, here's the expression, output is 3. So we have to calculate this, and if suppose 1 is only there, so we will return 1. And what are the constraints? That it can be 10 to the power 4, and s consists of English letters, digits, symbols and spaces. Okay, so we will have all 255 characters, 256 characters, ASCII characters. Total there are 256 characters with from 0 to 225. Okay, so let's start this question. I think first we will start with brute force. What is brute force? Let's create different types of substring first. Let's suppose this example, by this example we get we know what is substrings. Suppose how to generate substrings from A. First substring is this. From A we will try to create as many substrings as possible, A, B, C, then by using 2 for-loops, of course. Now we have to check this duplicacy. How we will check this duplicacy? By using a hash. What is a hash? It will be like a visited array which will contain that if we have visited this character or not previously. How? We will make a 256 length of hash. We will initialize it with 0, and it will tell, first of all, no one is visited, so 0. If we will visit A, we will mark hash of A equals to 1. So array will be something like what is the ASCII value of A? Small a, we know 67. So on 67 index we know A is present, and that A has value 1. So we can in big of 1 we can tell that it is visited or not, previously visited or not. And similarly, when we can break this loop here, and we can get the length 3. So let's start coding. We will comment this out. So this was the approach, brute force approach. Int I equals to 0 and I less than s dot size string size is calculated by size function, and we will make a hash. Hash array. See. Also we will make a int length variable. We will calculate the length from here, and we will start j from I, because suppose I is here, outer for loop I is here, we'll start with j here. If j is not in the hash, let's move ahead. If j is not in the hash, let's move ahead and increase the length. So, and we will calculate a maxi also, because we have to calculate the longest. So longest equals to 0. We will initialize it with 0, and suppose that if it is empty, it will be longest equals to 0, and will return 0 for empty. And j is also till last index. Now if we got in our hash, we got this character in hash previously found, so we will just break the loop. Why? Because we don't need to move ahead, because it will be repeated only. So if we not found the character previously in the hash, so we will increase the length, and we will update the longest with maximum value of longest. If length becomes more than this, then become this, we will use the max function. Simply we will return this longest variable, and we will format this code, and just we will submit. It will not be submitted because it will become 2 to the power. I have forgotten to write int. So let's run this code, and it is showing the wrong output. Why? Because I am not marking the hash. Actually, I have to mark hash also, that we have visited this character. See how simply we done this brute force. It will not be submitted because of time constraint. I think it is submitted because 10 to the power 4 and 1 second is 10 to the power 8, so we just beats 65%. This is not an optimal one. This is a true for loop. So we will now see the better solution of this. So before moving to the better and optimal, we would like to calculate this time complexity of this code. So time complexity is, I think we are seeing 2 for loop, and we are calculating every substring possible. So it is big of n square, and space complexity is, we are taking an hash array of 256, so it is big of 256. So let's move ahead with our optimal solution. Let's reset it. So now what can be the optimal solution? So we are studying sliding into playlist, and when we see longest substring, when we see substring word, then we must think that it can be 2-pointer approach. So let's take an example of A B C B D. So I will mark index also 0, 1, 2, 3, 4, 5, 6, 7. So let's start random. Suppose L is here, we will take 2 pointers, and R also here. Okay. So first of all, what we will do, I will create a map also. Let's create a map. Let's suppose this is our map. So in our map, first of all, what we will have it, we will move that we will see A is in the map or not. It is not in the map, we will put in the map, and we will mark the max length equals to 1. Now let's move our R. We will do R++, and how length is calculated? We will calculate length by R minus L plus 1. This is your max length. So now I think just not is 1, and we will do max of this, max of earlier max length, comma new. That's why it will update, because initially it was 0, but now it becomes 1 whenever R is moved further. So now R is here, it sees B, and it is also not in the map. We will update in the map B comma its index is 1. Now max length become R minus L, then 1 minus 0 plus 1 means 2. Now our R goes ahead. This is our R pointer, ABC is it will also go in map, and we'll update the length 3. R++ almost ahead. Now it sees A. So first of all it will see is it in the map? Yes. Is it in the map? We says yes. We find it in the map at 0 index, and its index is 0, which is it is found on our index 0, and our left pointer is on index, see, it is on index 0, means substring is, we've made the substring 0, 1, 2, 3, A, B, C, A, but A is repeated, and A is in the string also, because left pointer points in, and it is in the map also. So that's why we must see a condition that the character we found, it should be in the map, as well as the substring we made, the window, the sliding window from 0 to 3, A, B, C, A, the character is in this also. So a greater than equal to condition we must satisfy. Greater than equal to L. The map, suppose our map character index, suppose 0, here it is 0. 0 is greater than equal to 0, that's why it is in the map. So we should not take this. We will update the left pointer to now where we should keep our left pointer? We should keep our left pointer towards where we found the A, duplicate A, on 0 index, but again we cannot keep here, we will keep 1 index ahead of it. So we will keep it 1 index ahead of it. So we will do hash of SR plus 1. This means 0 plus 1 equals to 1. Now our L pointer is here. Okay, good. Now see, we updated our L. Now what will be our max length? R minus L. 3 minus 1, 2, plus 1, 3. It is same, 3. So let's move R. Now if we find B again, before we will update in hash also, we forget one step, that will mark the new index of it. So now A becomes 3, because we are storing the last index found, last C index, we are last from, A was last from. Okay, so this is one if condition, and if eligible and found in map, we found in map. This character we found in map is not equal to -1, because we will initialize our map with -1. Okay, so now L is here, R is here. Now B we found in map, we found it 1 index, and also L pointer is on 1, so it is greater than equal to 1, L 1, so means it is duplicate in our substring. So we'll increase the L to, and we'll also update the B's index, last found index, and our substring becomes 4 minus 2 plus 1 equals to 3, not changes. Now R plus plus. Now we find C. It is in our map. Yes. And its value is greater than equal to L. So it is okay. So we'll update the L to 2 plus 1, 3. And max length is also 3, only ABC. Now we will update the R. Now we find B and at index 6. But previously it was in the map with index 4, which is greater than or equal to our L. That means in this substring it is repeating, so we will have to update the L, but not here, because we are updating it the on one index ahead of the index which is repeating, the character ahead, duplicate character ahead, which was found in our map. We'll keep the update the L pointer from B plus 1. That's why 5 index. And we will update the now B index in this, and we'll move the R pointer. Again, we see that B is in our map and it is greater than or equal to L. So it is again repeating. So we have to update the L to B plus 1, which is here, and update the B's value to 7. Now while loop will end because it is become out of bound. So this was our answer 3. Hope you understood this. So let's write the code. We have mostly done our code. Only global variables I have to declare. Int max length equals to 0. And hash equals to 256. Now we have made our map with and initialize all the map values with -1 index. All the character values with -1 index. Now we will start the left and right pointer. We'll mark the left and right pointer to first index of our string. Now we'll start the while loop, and while loop will end when it becomes greater than the last index. So s dot size now we will check if it is found in map or not. So if hash of SR, because right pointer is first of all on 0 index, so if it's not equals to -1, that means it is in the map. If we found in the map, and if its hash value is greater than or equal to L, the condition I talked about, it should be greater than or equal to L, because that's what our window is. We have to see that in that window it is repeating or not. If it is in the map and it is in that window, that means it is duplicating. We do not have to take that substring. That's why we have to update the L to hash of SR plus 1 net ahead of this, because if we will keep on that only, then again it will become repeated in that substring. So this is okay. Now what we have to do, if it is not found in map, we just have to increase our max length, change our max length from L minus R plus 1, and we have to increase R plus plus. Also before that we have to mark in hash the recent index of the character in the hash also. Okay, so we will now return it. Max length. Let's see it runs or not. I hope you understand. English will gradually increase, but the flow. Wait a minute, what happened here is max length is R minus L plus 1, not L minus R plus 1. See, I will submit it. and one edge case will okay. Suppose it is a character of this length and I think L it is not in the map, so I should do one. Why it is not doing it? Okay, so the issue is we have to make all our values -1. Let's do it using this test case. What is it? To declare hash first. Hash. One edge case is this. I think there will be one edge case of empty string. Let's see. It is fast. Because it will be empty. It will not never go inside this value and it will return 0. Done. So now we will calculate the time complexity. See, while loop is running from the R index, the R pointer is running from 0 to n. So I think time complexity should be, what do you say? Time complexity should be big of n. And space complexity is same, previous 56 size array, so big of n. This is the perfect 100 by 100 solution. Hope you enjoyed the video. Goodbye.